Okay, here's your packet lesson, section 2.1, Pre-Calc B, linear and quadratic functions and modeling. So we're going to start out. These first 4 questions are just kind of terminology questions, all based on this. Polynomial form, positive exponents, and no radicals, okay? So, and then the question says, determine which of the following 4, it doesn't say that, but are polynomial functions. Well, if they have negative exponents, then it's a nope. And if there's radicals, then we say nope. Look at it, negative exponent. Nope. It says no radicals. Well, here's a radical, so we say nope. How about this one? Are there any radicals? Are there any negative exponents? So we say, yes, this is considered a polynomial function. It's just a definition, okay? And then this one's kind of sneaky because this one doesn't have any radicals. It doesn't have any negative exponents. If you wanted to get really fancy, you could say f of x equals, now watch this. Well, I'm going to hit pause on that and go to this, then it will make sense down here. Because this says, for those that are, you see this one is, and this one is, but we'll talk about this one in a minute. It says, state the degree and the leading coefficient. Now, the degree is the highest power of any one variable of that polynomial. So, the degree is 3. Then it says, what's the leading coefficient? The leading coefficient is whatever the coefficient of the highest powered term is. So the leading coefficient would be a 2. So that one's pretty straightforward. That's why I paused on this one. This one, technically, I don't know if you remember this, but what's 3 to the 0 power? Does anybody remember? It's a 1. So we're going to make this one really weird looking. It's x to the 0 with a 2 in front of it, because that's just 2 times 1. So, are there any radicals? No. Are there any negative exponents? No. So is this a polynomial function? Yes. What's the degree? Well, it's the highest power of the variable, which would be 0, strange one. And what's the leading coefficient? Well, that'd be my 2. All right. That's all warm up, you guys. That really doesn't have much to do with anything. Now, here it comes. Write an equation for a linear function. Root word of linear is line. And as soon as you see that, you go, hey, wait a minute. Y equals mx plus b. What are the 2 things I need to find? Slope and y-intercept. If you're watching my pre-lesson, all I said was, this is a fancy way of saying negative 3, 5. This is a fancy way of saying 6, negative 2. So here's x1, y1. Here's x2, y2. First thing we're going to do is find our slope using y2 minus y1 all over x2 minus x1. So here we go. Y2 is negative 2 minus 5. X2 is 6. Watch out for these double negatives. These are the ones that get you. And so I get negative 7 all over 9. I take that and I put it right in the M spot. Then I pick either this point or this point, and I put it in here, and the only thing remaining would be B, and that's what I need to find. So I'm going to grab this and this point. So that'd be Y, right from there, equals M, negative 7/9, X, right from there, plus B. Now this is looking a little messy, but hey, life is a bit messy sometimes. These make a positive. I'm going to cross reduce. So really, this is 7/3, so I'm going to rewrite it. A lot of you don't like, to this day, finding common denominators, but minus 7/3 minus 7/3. I know that 5 is 15/3. 15/3 minus 7/3 is 8/3 equals B. So now I have my B. It's my y-intercept. I got my slope. I put them together. Y equals negative 7/9 x plus 8/3. There it is. Okay? There it is. Now, very similar problem right here, just different stuff. Now, the first thing I'm going to look at, do these things match? No. Do these things match? No. So it's not one of those easy ones I explained in the pre-lesson. So here's my first point, x1, y1. Here's my second one, x2, y2. And I'm going to find my slope. So this minus this is 5. And then x sub 2 minus x sub 1 is 4. And there's my slope. So I'm going to grab this point, go y equals mx plus b. See, this is just 5/4. So I'm going to subtract 5/4. Subtract 5/4. Again, common denominators. I'm going to make that 8/4. So what's 8/4 minus 5/4? 3/4 equals my y-intercept. I got my slope. I got my y-intercept. I'm going to put them together. Y equals mx plus b. There it is. So there's your linear functions. Now we're going to get into, look, it says linear and quadratic. So quadratic means parabolas, linear means lines. Okay? So dive in. Now they're going to warm you up with a straightforward graphing problem. So we know that a typical f of x equals x squared is just going to have vertex 0, 0, and it's going to look like that. You just have to get used to it. Okay? This says, where'd the vertex get moved? Where is it now? Well, this says we're going to move that vertex left 2. So we're going to go ding, ding. So we know it's -2. And then this is going to move it down 1. So it would move left 2, down 1. There's the new vertex. Now, I do know a couple other things, that it's flipped. And it's also going to be skinny, vertically stretched or horizontally shrunk. So I'm going to make it super skinny. Maybe that's too skinny, but that's what happens. Now the axis is the axis of symmetry, which means it cuts it right in half. Now in this case, there it is. Now we've talked a little bit about vertical lines, and that's going to be x equals -2. All vertical lines are always x equals. Now, what about this shift? Well, it went left 2, down 1. We kind of already said that with the vertex. Now, does this open up or down? Opens up downwards because of the -a. Okay? There's a warm-up, but the real challenge is, how do you take something like this and make it look like this so that you can graph it? It's called completing the square. So I talked about it briefly in the pre-lesson. Now we're just going to do it. This we're just going to turn into y. These two things we like because that's going to build our trinomial, but watch what I'm going to do to it. I'm going to add a space, and I'm going to put brackets around it so your brain can process it. Plus 12 plus another blank. This is where my perfect square trinomial is going to come into play. How do you complete the square? Well, you got to have a 1 here. Now notice there's not a 1 here, and there's not a 1 here. And this one's a little bit wonky, but this one's the easy one, so we can get right after it. Well, what if it's not? We'll talk about it in a minute. There's a little trick coming. All you do is you take half of that, so I call that the middle term coefficient. I'm imagining there's something here in a trinomial. That's why I call this the middle. But what's half of -6? -3. Squared is 9. But if I put 9 pounds on this side, and I think of this as a teeter-totter that's perfectly balanced, because that's what equals is, if I put 9 on that side, I got to put a -9 on that side. This is a perfect square trinomial. So I go y equals x minus 3 squared plus 3. And see, now I can find the vertex and the axis of symmetry. So I go like this, and I think, okay, where does the vertex move? It moves to the right 3, 1, 2, 3, and then up 3, 1, 2, 3. Because there's an invisible 1 here, that means it's positive and it's normal. Because remember up here, there was a 1 up here. So it's just a normal parabola opening upwards. But what's the axis of symmetry? It's a vertical line that cuts it in half, and that happens to be x equals 3. And the vertex is 3, 3. That's what it's asking us to find. the vertex, and the axis. Okay? All right. Next one's going to be a little nastier. So here we go. It's been a long time since you've seen anything like this. It's similar, but it's different. Now, here's the thing. Do you see this? That turns into my y. Now, some of you are already thinking ahead maybe, and you're thinking, aha, if this needs to be a 1 like he keeps saying, then I'm just going to divide this whole thing by 2. Problem is, you don't want y over 2. You see, the general equation of any parabola is always y equals blah, 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 blah. So you don't want y over 2. So dividing by 2 is a good idea, but it messes things up more than it helps. So what are you going to do with this? I want you to concentrate on these first two terms and say, wait a minute, what can I factor out of there? I can factor a 2 out. Now what would be left? X squared minus 6x. Now watch this trickery. I know I have to have a perfect square trinomial, so I'm going to prepare for it. And then I'm going to go plus 23 plus blank. Now's where a little twist comes. Take half of this, negative 3, square it is 9. Now I know you guys want to put a negative 9 right there to keep balance. But look, see this little sneaky 2 out in front? What's 2 times 9? 18. So it's really like I added 18 pounds onto this side of the seesaw, teeter-totter. So I have to make up for it by subtracting 18. That's a little tricky. Now let's clean this thing up. Y equals 2 times x minus 3 squared plus 5. After all that work, I finally got something I can read. Where's this going to take the vertex? It's going to take it right 3. Where's this going to take it? Up 5. So it tells us our vertex is 3, 5. Now if I was to kind of paint a picture of what's going on, 1, 2, 3, 1, 2, 3, 4, 5. This isn't going to be perfect, but it's a little bit, well, it's vertically stretched, horizontally shrunk. In other words, it's skinny. So, and it opens up upwards. But then I draw in my axis of symmetry, and that is x equals 3. There we go. So, we got 12 minutes. I'm just going to go ahead and stop this recording with 12 minutes, 12 and a half minutes. There's only like 2.5 minutes left. There's no way I'm going to finish these 3 problems in 2.5 minutes. This is just a long lesson, packet lesson. So I'll see you at part 2.